Hello everybody, I'm Elena.
And I'm Simone.
We are to tell you about the experiment we have executed with our class about two important concepts in physics, impulse and momentum.
Please don't feel scared by these terms. Understanding them just requires basic knowledge of dynamics and kinematics. Even if you're not versed in physics anyway, you should find interesting our experiment.
Yes, we're going to experimentally demonstrate the momentum theorem, but before that we should rather get to know what impulse and momentum are.
Yeah, let's show them. Now, impulse is the product of the force and the time. And the momentum, which is another physics measure, is the product of mass and velocity. Now we know what the definition of impulse and momentum is, but what is the relation between these two physical quantities? It is determined by the momentum theorem. Let's try to understand it. We're going to discover something very surprising.
Here we come, driving down, deep and wide.
And what we want to do is to demonstrate the theorem of the momentum, which is that the impulse is the difference between the momentum calculated on the final velocity and the momentum calculated on the initial velocity. So what we have to do now is to write the second principle of Newton and then substitute some equations in this one. So now we can write that the impulse equals the mass multiplied by the acceleration multiplied by the time. So now we can write this. Which means that the acceleration is the difference between the final velocity and the initial velocity. So this is another way to write the acceleration, and then multiply this by delta t. È andata via. So now we can do this. And our relation is demonstrated. The teacher told me that the mass was missing. Yeah, that's right. Okay, now this is our relation.
This is such an important relation in physics.
Right, maybe you don't know that Newton's second law, which is probably the most important law in classical physics, was initially presented with this equation, which is an important step of the mathematical proof we have just shown you. This is another reason why impulse and momentum are two very important quantities.
Now what we want to do is to check if actually impulse equals the momentum variation. It means that we want to verify if the product of the force that acts on an object and the time the force acts on the object equals the difference between the final and initial momentum of the object.
Yeah, and in order to do this we have to use the tools of our physics lab. Now let's see what these tools are. Sì, dopo guarda che si può. Vai. Ok, questa volta non ha fatto niente. Ma grande. This is the force sensor And this is the position sensor.
This is a rail.
And this is the rail, the track on which the slider slides, and this is we have put this metal bar here in order to make the position sensor see our glider and record its position during a period of time. And when the glider hits the force sensor, the first sensor measures the force with which the glider hits it.
So we have a rail, a glider with a paper cushion that makes it not to fall when it hits the force sensor, a computer, a position sensor and a force sensor. What the experiment requires to do is giving the glider a push of short duration in order to make it move towards the force sensor.
The position sensor and the force sensor have the same sample rate of 10 Hz. This is very useful because it allows us to record the force and both the force and the position in the same instance.
Now, time to execute the experiment has finally come. Now we start recording position and force with a sample rate of 10 Hz.
Miles and miles of sound, endless roads twist on.
Yeah, executing the experiment is really that simple.
Nothing really exciting so far. The finest part of the experiment has yet to come because we haven't compared the momentum and the impulse yet. What we still have to do now is to select the data to process in order to calculate them. So let's start with the force. As we can see in the graph, the force acts on the glider from the 1.0 seconds instant to the 1.2 seconds instant. This means that the time interval we need to calculate the impulse is the difference between these two values, which is 0.20 seconds. For what concerns the force, we can't keep 2.8 Newton as the force value, because in order to calculate the impulse, we need the average force in this interval. Luckily, we have recorded the forces at the endpoints of the interval and in its middle. This means that finding the average force just requires calculating the average of these three force values. It wouldn't have been that easy if the forces had been recorded in a different way. Finally, we have our average force value, which is 0.9 Newton. We have to put the minus sign before this value. In fact, force and velocity are two vector quantities. Since the initial velocity and force have opposite directions in our experiment, we have to do this. Obviously, the velocity will keep the plus sign. Now that we have calculated the quantities with which we can find the impulse, we also have to calculate the quantities with which we can find the momentums of the glider before and after hitting the force sensor. First, we need the mass of the glider.
Now we are measuring the mass of our glider.
What's the mass?
359.29 grams.
Okay, right. Good.
Now we need to find the velocities. By watching the space-time graph, we can notice that the lines that connect the points are mostly quite straight. This means that the motions of the glider before and after hitting the force sensor are approximable to linear uniform motions. Because of this, we can assume that if we calculate the velocity in any interval during these motions, we'll be able to keep it as the velocity the glider has before hitting the force sensor in the case of the initial velocity, or as the velocity the glider has after hitting the force sensor in the case of the final velocity. So, let's calculate the velocities using the space-time intervals just before and after the glider hits the sensor. Here they are. The initial velocity is 0.62 meters per second, and the final velocity is minus 0.33 meters per second.
That was quite boring.
Come on, the exciting part is coming.
Finally, we have enough data to calculate both the impulse and the momentum variation. Let's do this.
I'm waiting, longing for
My God.
you.
Impulse we have calculated with the difference between the final velocity and the initial velocity is equal to the one we have calculated with the force. And this is one of the most exciting moments of my life.
Our goal was achieved. The momentum variation really equals the impulse.
I'm still feeling so excited.
Oh, come on.
Thanks for watching.
See you at the next experiment.
Crazy how that we just only met alone. I am your visitor. I'm on the other side of your wall. My whole world at night. My whole world at night.
Hello everybody. What the experiment requires to do is giving the glider a push of short duration in order to make it move towards the force sensor. Yes, executing the experiment is really that simple.
Nothing, guys, sorry.
Yeah! Yeah, executing the experiment is really
Hai
that
sbagliato a pronunciare.
Yeah, executing the experiment is really that simple.
Così mettiamo sta roba qua senza sonoro. Comunque i video in cui spieghiamo l'esperienza possiamo farli anche a casa tua se proprio non riusciamo a fare le scuole.
No, dobbiamo fare comprare le
Non c'è ma il carrino l'abbiamo già fatto, comunque la seconda esperienza non possiamo farla. Cioè, già non so se riesco a dimostrarla prima. Sì, ma se dobbiamo fare una cosa facciamo che sia poca ma che sia fatta bene, mi sembra, no?
Questa volta mi trovi d'accordo con molto Dio. No.
No, è servita, almeno fare quella e...
no, perché il pesetto?
Però vabbè, mi dispiace. E fai le cose senza interpellarmi.
Sì, che ti ho interpellato.
Allora, F uguale M per A.
Sono arrabbiata. I'm angry.